everyone. So today I'm talking to Ambiq Micro's Dr. Adam Page, and we're going to be looking at the additional dimensions around Edge AI implementation. Hi, Adam. How are you?
Doing well. Thank you for having me.
Good to speak to you. Great. So, though AI processing resources are vital in edge-situated inference work, there's all sorts of other aspects that we need to consider too. So maybe to begin with, let's talk about data management and storage. I mean, the memory reserves are clearly going to be fairly limited when you're talking about stuff at the edge.
Right.
And, obviously data must be stored as efficiently as possible because of that. But also, there's going to be power budget considerations when you're moving data around and so forth. So, for instance,
Right.
I'll take a body-worn medical monitor, I don't know, an industrial IoT device, and that's constantly generating data. And, how are engineers going to go about keeping down those overheads as much as possible?
Right. Yeah, so when we think of like Edge AI, it's usually focused on the inference part for efficiency. And for
Yeah,
Ambiq, we've realized, we deal with a lot of customers, and for them, data is key, right? They want to preserve that data
sure.
both locally for context, as
Yeah,
well as later for A/B testing, for cloud-based reasons as well.
yeah,
So we've actually looked to tackle this. We have something we call compression kit.
yeah,
The idea for this is it's geared towards around wearable sensors. So
yeah,
you can use it for physiological sensors. Imagine you have like an ECG Holter
yeah.
device, and you're capturing 2 weeks of data. That's a lot of data that needs to be captured, right? And
Mm,
usually these are periodically synced. They don't want to always wake up the Wi-Fi or Bluetooth chips to transmit this out. So
sure.
by using compression, it's using AI-based techniques, so like a neural codec to do this. What effective they're able to do is we have found cases where they can get up to 20x compression,
Okay.
and it's lossy, but when you're thinking about wearable devices, there's inherent noise when you're doing this, right? These are ambulatory environments. There's a lot of
Mhm.
noise going on, industrial
Yeah,
IoT.
yeah,
So what we look to do is essentially, if you think of compression, it's almost there's two sides of a coin, right? One aspect is compression. The other side, it's like tokens. So
mhm.
you can kind of think both techniques to address the data volume that you're dealing with. So you look at like small language models, large language models, right? We think of tokens.
Yeah,
Compression is that same kind of modality, and it's a foundational technique where you want to preserve the important pieces, but remove the
yeah,
things that are not important, right? The noise, the
mm,
artifacts that you don't care to preserve.
yeah,
So we've tackled this, and we've focused mostly on wearable devices. That's what our customers use today. So you can think ECG, PPG sensors, IMU accelerometers.
yeah.
It's very good for wearables. We're even seeing cases now for smart glasses as well. You can
Okay.
imagine if you're doing vision applications, audio applications. There's just a lot of volume of data, and
Yeah,
data needs to be stored on device, right? If you don't have sufficient, you're using external memory. That's very costly and power
yeah,
inefficient. And then
yeah,
at some point, you're transmitting this to cloud, which again is a tax that you have to pay to transmit all of
mhm,
that data.
yeah.
So for Ambiq, we focus on the entire pipeline that includes the inference piece as well as the pre-processing, post-processing, and the fact that ultimately that data needs to be sent somewhere.
Yeah. So a couple of things there is obviously, as you said, that, say in a medical, body-worn medical item, then you've got the actual data you want to, actually, that's the key bits you want to keep. But obviously there's a
Right.
lot of other background stuff going on. And the same
Hmm.
in industrial IoT, there's going to be a lot of things. So you want to obviously keep that valuable data as much as possible and get rid of as much of the other stuff, because if you're storing that or having to transfer it, you're either wasting bandwidth or you're wasting memory resource, because that doesn't actually serve any
Exactly.
purpose.
Yeah.
Just coming back to that, as you said, like a smart glasses example. So would that be, because obviously that could be taking lots of data, but it's only really interested perhaps in certain aspects of that, like movement or events or something like that. So is that how you can get rid of some of that background information that's not really that important? Is that how you see it?
Right. Yeah. You
Okay.
can imagine there's like audio cases, right? You're doing beamforming. You got multiple channels of audio that you're having coming in. And
Yeah.
now you need to just say, hey, I want to do speech enhancement, or I want to do some
Yeah.
kind of local processing. Compression kind of goes hand in hand with that. You can compress it. You can, in some ways, maybe not so for smart glasses, but if you think like wearables, let's say
Yeah.
you have like a PPG signal. If you
Yeah.
compress that representation and you do it in a clever enough way, you can actually do localized AI on that compressed representation. So
Mm.
not only does
Okay.
it give you a more compact representations for transmitting or for storage, but you actually can reason on that compressed representation.
Okay. But as you said, then you can compress it, but while still retaining the quality needed for actual inferencing. So you're not
Right.
losing any of that. Okay, so that,
Right.
but that's obviously the important thing, is you don't want to compress it and then find out that you've lost any of
You've
the,
lost a good piece, yeah.
yeah,
And that's something we work with customers to try and pick and choose which things they're after. Usually, if you do traditional techniques, the
yeah,
issues you see there is you look for ECG or physiological signals, the noise is, it kind of overlaps with the bandwidth or the signals of interest, right? So it's really tough to tease those out. Using AI-based neural codecs, we can be a bit more smart about this and actually preserve the pieces they care about. So usually when we work with customers and they're interested for like ECG or PPG, we can do standard kind of metrics like how much root mean error there is, but then we also look at secondary metrics. What is the heart rate and heart rate variability? Are those retained and we're preserving those? Are we preserving the morphological kind of aspects of the signal? So we have these different things that we actually train against so that the model's not, A, it's not hallucinating, it's actually preserving what it can, and B, it's preserving the things that are of most utility for downstream tasks.
okay. Because as you say, then if you lost the quality of the data, then you're inviting that device to make mistakes that could lead to hallucinations of some sort. Okay, so
Right.
quality's
Yeah,
got to be maintained. So that's cool.
absolutely.
But just coming back to your original point, then is obviously the Ambiq's already gained a reputation for making the actual inference side of it as power efficient as possible and making order of magnitude improvement there. But
Right.
it's not purely just that. Then people have got to think about it. It's what happens across the system, basically.
Right.
Then. Okay.
Yeah, and I like to usually follow the data from where it's going from sensor to what you're inferencing on to how you're pre-processing or sending it to cloud. We're seeing a lot now that people want localized intelligence. So they don't want to just purely send that data to cloud. They want to do stuff locally with that intelligence, right? They want to be able to understand. I want to be able to ask my watch or my phone, how's my run today compared to yesterday? Well, that's not only preserving just the raw kind of heart rate, heart variability, but it needs to understand nuances with how things are changing with time. So it's good to kind of keep that data local as well for any kind of local intelligence they have or any kind of small language model that they may have with it.
Yeah.
Yeah.
Because then, as you say, it's no longer just sort of, edge AI, I guess. Originally, probably people thought, okay, that's, it's processing data to say, right, for instance, an AMR or something's got to work out, right, is that an object or that I can go around? Is that a human being that I need to be careful? That
Right.
those items are probably data that's just needed for that, instance. Whereas, more nuanced data, which sort of you need to understand trends, or you need to have access to make other
Right.
other insights about. I guess it's important to keep that as for a longer period. Then, yeah.
Right. Especially like multimodality, you want to preserve that. You want to look for seasonality, things that are more short-term trends versus long-term trends, right? Anomalies that might happen. So it used to be Edge AI was more of these kind of smaller models that kind of just did one thing, but now we want to have models that kind of understand each other. There's a whole mixture of experts that's becoming popular, right? We don't want just one large language model. We want to have smaller ones and mixtures that we can kind of choose and experts to choose between.
Yeah, because it's going to be a bit more sort of multifaceted, more holistic approach, that you're going to be getting different data streams from different things and different sort of multimodal sort of. So it's going to be much more complex in that respect, that you need to keep all the different items of data for longer, because they're all going to sort of contribute to a bigger picture.
Right, absolutely. And I think people want to engage naturally with this. Like voice UI is something that we're looking to kind of really focus on this year. People want to speak naturally to their devices, not having to touch and go through different menus and interfaces. So the voice UI, you want to be able to more naturally kind of ask it and query it questions and get responses that understand who you are, understand your personal differences, right, uniqueness, and pulls that into account rather than just sending everything to the cloud, right? This is a continuum. Cloud is super useful. That's where we can run much larger models, but we still need more localized models as well.
But it's interesting because it does sound like obviously there's always going to be a place for the cloud, and there's obviously, your longer term, much more detailed analysis can still be done there, but quite a lot more is going to be possible at the edge by the sounds of it as well than would have been first imagined. Everyone would have assumed, okay, that's restricted to what you can do there. But by the sounds of it, the more, so and this, we're only still at the beginning of this, but if we can compress the amount of data, make that sort of as streamlined as possible, then we can continue to do more at the edge without having to need cloud to, sort of
Right.
resources.
Absolutely.
Okay.
Yeah, I think it's distributed intelligence is what I kind of see it. And so for Ambiq, what we're really striving for is intelligence everywhere. That's kind of what our name stands for, ambient IQ. So artificial intelligence is clearly how we're doing that today. And our Spot platform is essentially how we make things run more efficiently on our silicon. And then top of that, what we're providing to our customers is a whole ecosystem, which we refer to as the Heli AI ecosystem. So we're providing our own runtimes, our own kernels. For example, we recently released Helia Core.
Yeah.
That's doing all the low-level math that needs to be required for these AI models. And we make it work across all of our silicon. So the idea is, instead of being like a walled garden or doing things different because it's edge AI, we're trying to do this the same way you do this if you did cloud AI. It's the same way you want to train. If developers are using JAX, PyTorch, we want them to use that. And we're providing those tools that get them that last mile to effectively deploy and run efficiently in our silicon.
Okay. Well, let's move on to that, because obviously, the whole development process is really important. And, basically, you want to make that as quick and as risk-free as possible. You want to try and keep the sort of, the engineering issues down. I'm sort of assuming that most of the companies you're dealing with, they understand their applications really well, but they probably got little or no experience possibly of edge AI inferencing before they start the projects that you're working with them on. So, first of all, I mean, you started to sort of intimate some of it there, but what are the things that they're expecting the most support upon, from you, would you say?
Yeah, I would say our customers, we see there's a mixture. There's definitely some customers who have an entire AI team. And for those, they already have models that they wanted to bring. And they're just saying, hey, how do we deploy this efficiently? Then we have other customers who have like little to no kind of AI teams whatsoever. And for those, we try to provide a full kind of experience, a full solutions as well. So for that, we actually provide these, what we call AI development kits. So we have one for like Heart Kit, we have Sound Kit, Physio Kit. Next, we're gonna have like Vision Kit. The idea is we basically provide the developers an experience where we have lots of different models, lots of different data sets, lots of different tasks that they can start from. But we do it in a way that allows them, it's flexible, modular, so they can bring their own data set. They can swap out a task for a different one. So we do provide that. We also provide more of like a white glove service where it's, if you need more help with getting things running, we have a whole team to kind of support that initiative as well. And again, I think the biggest thing is we're just trying to make sure we play with the bigger ecosystem that's out there, rather than just saying, hey, we have this walled garden. We want to kind of work nicely with what's out there, because that's the way of the future, right? We need to have publicly facing open source code that developers can use and interact with in a more natural way. We don't want websites that, like portals is not my vision, where you have to go into like do AutoML. Usually data scientists want to have coding on hand, or at least make it easier for agents to run as well. So that's something big that we're going with as well, is to make it easy for both humans as well as agents to start developing and deploy to our silicon.
Okay. But as you say, it's got to go down an open source route, because having sort of siloed, sort of protected.
Yeah, we want to have standards. So we try to follow, if it's TOSA or if it's A10s, we want to make sure there's standards that we're following so that everybody knows, like, this is the standard we want to go to. We support these kind of model architectures, which is rapidly changing, right? Every month there's new kind of architectures out there. So by sticking to the standards, we make it much easier for our customers and developers to train their models however they see fit using the latest technologies. And we just help to kind of bridge the gap to deploy it now efficiently.
So, as you said, though, some companies will have bigger development teams. They'll be able to do a lot of this stuff themselves. Other companies will need access to, to models which are, at least get them close to what they're trying to do. Because I guess, as you say, that there's certain models that are, everyone's going to have a slightly different take on it, but there's probably some, commonalities in terms of, is it going to be voice recognition based? Is it going to be object recognition based? Is it going to be, sort of.
Right.
Yeah. Okay. So,
yeah, absolutely. Yeah. And so we provide a model zoo, but historically model zoos can be very much static. It's like, here's a snapshot, and if it works for you, great. If it doesn't, you have to kind of figure out how to do it yourself. So the idea is we have these AI development kits. They're open source. This is what we use to create our open source models. And we usually put them on Hugging Face just to make this easy for everybody to get started. We want to keep it the same as if you're doing this if it's edge AI or cloud AI, we want it to look the same. So we also put all this in Hugging Face. We're going to be building this out over the coming years. So the idea is they can try out the models. We have demonstrators that we put together for them to experience how well the models work. And if they want to go build it themselves, they can, or they can lean on us if they want to. And we also, a big area is we really want to work with model providers.
Okay.
Right, that's a common trend as well. Is there's a lot of kind of data set providers, and now there's a lot of model providers that the Ambiq is looking to work with.
So that'll be a whole ecosystem that you're trying to sort of put together based on that, and obviously then having platforms like Hugging Face, then making that available to to the general public. For
Exactly.
sort of okay, so that's cool.
And if our tools are open source and public, this makes it easier for model providers as well to kind of work with their ecosystem, right? It's not some walled garden again, so they can more easily kind of integrate their models, make sure it works efficiently. And we provide tools like profiler tools, so any potential customer can come buy one of our evaluation boards. They can plug it in. They can select a bunch of models that we have for free, and they can go profile and look at the performance. We can do deep dives. We can look like per layer. We can do PMU counters. We can capture power. This really allows them to understand exactly how much, in terms of budget, this is going to cost them. Lots of kind of different ways that they can navigate and explore.
So they get a visibility then of what's going to be involved in terms of the engineering effort, the financial budget involved, so forth. So they can sort of get an idea of what they need to invest and what So okay, so that's cool. I mean,
exactly.
Yeah. With a lot of these companies and certainly the applications that we've talked about earlier, things like wearables and so forth, especially, you're going to have limited windows of opportunity in a lot of these cases. So I guess having, sort of a short development times and getting started and getting to, to market as quickly as you can is going to be really vital for a lot of the people you're talking to. Yeah.
Yeah, exactly. So we try to accelerate that whole development cycle.
Yeah.
We don't want it to like, hey, go figure out how to get this stuff working. We want to help to accelerate that. So we provide ready-made solutions. We put stuff on Hugging Face. All of our kind of repositories are on GitHub, and we make them to be, they're CLI based, but they're also programmatic based as well. So people can actually integrate them with their CI/CD pipelines, so they can understand if there's any kind of deviations. They change certain parameters. How does that impact it? So all the different tools that we're building out, it's all Pythonic. It's all meant to be open source. We have APIs that are standardized, and we find customers really they appreciate that. It's much easier for them to get started, and again, we have lots of documentation and getting started guides for them as well.
Okay, cool. But obviously, you're giving away a lot of stuff, as effectively for free and putting a lot of effort into making that. I guess the payoff though is, from a silicon point of view, you're in a strong position that you can give them the Apollo socks that will then enable that to happen. So it's sort of, back in the history of semiconductor technology, people, Intel did this. They gave a lot of additional support away purposely with the view that because their technology that backed this up was so strong that they would reap the rewards. So you're confident that that's gonna come back to you in terms of
I think our Spot platform is very strong. The fact that we can do sub-threshold means we're orders of magnitude lower power. That's our bread and butter. And the Healy AI ecosystem that we're building out is basically looking to take as much advantage of that as possible. So yes, it's public. Yes, it's open source, but it's very much hyper optimized for our silicon. So we do very much different techniques. We know the different memory layouts, the fabric speeds. We optimize for those things. So our runtimes and our kernels that we have are very much hardware aware and designed that way.
Yeah. So as you said, they're optimized specifically to work with your socks and so forth. So to get the full benefits of that, they're going to want to work with you on that.
Exactly.
We've already touched on the fact that more stuff it's a lot more stuff could be done at the edge now than even could have been thought about just a couple of years ago, I'm guessing. I mean, where do you see edge AI going at, sort of in the next 5 or 10 years from now? I guess it's a tough question to predict at the moment because it's accelerating so quickly, but have you got any sort of ideas where you would think things might progress?
Yeah, I mean, if you look historically, almost everything AI related was done in the cloud. And over
Yeah.
time, we're chipping away at that, and more
Yeah.
is being done now at the edge. And I think that's going to continue to happen. The biggest area I see for that is with language models. Today, that is still very much cloud focused.
Yeah.
But now you're seeing where people can start running them on laptops. You're starting to see tinier language models that can run on cell phones.
Yeah.
With our next generation products that we're putting out there, we can start doing some kind of lightweight reasoning. We can do some kind of tiny language models. So I think voice UI is definitely a big area that we're going to see for the next couple of years. And then getting into vision, I think that's another big area. That's costly to send all of those pixels to the cloud. So the more that we can process locally is going to be, huge savings, even if it just means tokenizing it locally so that transmitting is not transmitting all of the raw data.
Yeah. But like you said, then maybe just giving back the actually, the very key parts of that rather than whole streams of it. Okay, so
right.
The possibilities for Edge AI to become a stronger part of the whole overall picture, are compelling.
Absolutely, yeah.
So as you mentioned, obviously, things like vision at the edge are going to be. I mean, I guess that's starting to happen now, but it's going to be further down the line. That's going to be much more sophisticated in how that's done. So, are there any other areas going further out again? Do you think there's other sort of possibilities that you'd see?
I mean, I think everybody's talking about like agentic workflows and the fact that when they speak naturally to their devices, I think that's going to become a bit more ubiquitous. There needs to be more standards so that, like, if I want to ask questions about other things in my home or in an industrial environment, you're going to get answers back. That's going to be tailored to your question.
Mm-hmm.
So I think having localized intelligence and the fact that we need intelligent systems that can communicate with each other, right? It's not just one giant language model. There's going to be lots of these kind of more experts of models. If you're in an industrial environment, there may be ones that are monitoring lines that you have. You may have ones that are looking for supply chain issues. And then you want these different systems to communicate together.
Yeah.
So I very much find it's going to be localized intelligence that needs to be able to communicate and understand each other versus just a big monolithic model that's in the cloud.
Yeah, that makes sense, because then obviously if you can have that interaction between more things at the edge, they can all, sort of support each other or draw upon each other's insights, then that's got to be a value. And as you say, then also, if you can have more personalized sort of the way, answers are more personalized to what your actual sort of, your character is looking for, then I guess that's adds value as well, because it doesn't just become a generic sort of thing that that is not sort of taking into account your own sort of personality then. Okay, so that's
I think context is going to be key, right? Some of that exists today, but it's very much looking for very common patterns. It's not quite personalized, in my opinion. If you're wearing like a smart ring, or maybe sometimes that data is not accessible to something else on your phone, this is where those intelligence kind of systems need to communicate, so that when you ask questions, it has better context about who you are, can make better, give you better answers that are suited for what you're after.
Excellent. Just one final thing in terms of your own roadmap. I'm sure you can't go into too much details, but I'm guessing the company's going to move forward with the actual Apollo socks and so forth, and also the supporting platforms that go with that. Is there anything you want to mention that you see as being important for your progression as a company over the next year or so?
Yeah, I would say on the software side, we're going to continue investing, especially around AI. It's becoming a requirement now for customers to say, does it fit these kind of specs? On the hardware side, I'm very excited about our next generation Atomic platform that's going to be launching early next year.
Okay.
And that is going to allow for more to kind of next generation AI workloads. Not so much as it just speech enhancement or heart rate arrhythmia detection. This is going to kind of, it has Ethos U85 in it, but it also has stacked DRAM memory, up to 256 megabytes of memory, which is quite sufficient to do lots of kind of more complex, even doing like tiny language models become a reality now. So this is what we're super excited about. We're going to be building a voice UI kind of experience around this. So that's why I'm excited. So that's hopefully going to be available early next year for alpha customers to kind of get a hold of.
Okay. Well, look forward to hearing more about that in the new year. Great. It's been a real pleasure speaking to you. Thank you so much. And
likewise.
hopefully get to talk again. Okay. Cheers, Anne. Thank you
Sounds
very
good.
much.